Hello, and welcome to our lesson on the highest common factor, or HCF. In this lesson, our focus will be on understanding what the highest common factor is and how to find it. Here's how we'll proceed. We'll introduce the concept of the highest common factor and explain its significance. Next, we'll step through the process of finding the HCF using prime factors. After understanding the process, we will run through some cases applying this new knowledge to solidify your understanding. So far, we have become familiar with the concept of prime factors. You know how to break down numbers into their prime components, which is a crucial skill that will help us in finding the HCF. With this strong foundation in prime factors, we're now ready to introduce the technique of finding the highest common factor. Knowing the HCF is incredibly useful when simplifying fractions, solving problems involving ratios, or even tackling more advanced number theory. For instance, if we have two numbers like 48 and 180, knowing their HCF helps us simplify the fraction 48 over 180 effectively. Understanding and using the HCF can make seemingly tough mathematical problems much more manageable. First, what is the highest common factor, HCF? The highest common factor, or HCF, of two or more numbers is the largest positive integer that divides each of the numbers without leaving a remainder. In other words, it's the biggest number that fits perfectly into each of the given numbers. For example, consider the numbers 12 and 18. The highest common factor of these two numbers is 6 because 6 is the largest number that divides both 12 and 18 exactly. Now, let's look at methods to find the highest common factor. First is method 1, listing factors. The first method to find the HCF is by listing all the factors of each number and identifying the largest factor they have in common. Factors of 12 are 1, 2, 3, 4, 6, and 12. And factors of 18 are 1, 2, 3, 6, 9, and 18. Looking at these lists, we identify the common factors, 1, 2, 3, and 6. The highest of these common factors is 6, so the HCF of 12 and 18 is 6. Now let's look at method 2, prime factorization and Venn diagrams. The second method involves breaking down each number into its prime factors and then using a Venn diagram to identify the common prime factors. Step 1, prime factorization. Prime factors of 12 equals 2 times 2 times 3. Prime factors of 18 equals 2 times 3 times 3. Step 2, draw a Venn diagram. Create a Venn diagram with two circles, one for each number, and place their prime factors in the appropriate sections. For 12, the circle contains 2, 2, and 3. And for 18, the circle contains 2, 3, and 3. These circles will overlap where the numbers share common prime factors. Step 3, identify the intersection. The intersection of the Venn diagram represents the common prime factors. Both 12 and 18 share the prime factors 2 and 3. Step 4. Find the product of the intersection. Multiply the prime factors in the intersection to find the HCF. HCF equals 2 times 3 equals 6. So the highest common factor of 12 and 18 is 6. In this diagram, the left circle represents the factors of 12. The right circle represents the factors of 18. And finally, the overlapping section, 2 and 3, shows the common factors. The product of the common factors, 2 and 3, is the HCF, which is 6. By using either listing factors or prime factorization methods, we can determine the HCF of any set of numbers. With practice, you'll find these techniques become second nature, making it easier to work through a variety of mathematical problems. For case 1, we will work through a practical scenario of highest common factor, HCF. Let's imagine that we're arranging a school fair and need to split students into equal groups. We have 48 students from Year 10 and 180 students from Year 9. We want to mix the students from both the years and form the groups such that each group has an equal number of students. How can we find the optimal group size? This is where the HCF concept comes into play. First, let's take the numbers 48 and 180. Step 1. Let's find out the prime factors of 48 and 180. The prime factors of 48 are 2, 2, 2, 2, and 3, or when written in exponential form, 2 to the power of 4 times 3 to the power of 1. And the prime factors of 180 are 2, 2, 3, 3, and 5, or when written in exponential form, 2 squared times 3 squared times 5 to the power of 1. Step 2. List down all the common prime numbers present in the prime factorization of both the numbers. Here, the common factors are 2 2's and 1 3, or in exponential form, 2 squared times 3 to the power of 1. These are the prime factors that would be in the intersection in a Venn diagram. Step 3. Multiply these common factors together, and this gives us the HCF. So, 2 squared times 3 to the power of 1 equals 12. This means the most significant number of students that can be in each group, so that groups are the same size and there are no remaining students, is 12. For case 2, let's look at a more complex example. Now, what if we are given two large numbers such as 2700 and 3600 and asked to find their HCF? Step 1. Let's find the prime factors of the numbers. For 2700, it would be 2 squared times 3 cubed times 5 squared. For 3600, it would be 2 to the power of 4 times 3 squared times 5 squared. Step 2. Let's now identify the common prime factors. We have a couple of 2s, a couple of 3s, and a couple of 5s. Step 3. Multiply the common prime factors. 2 squared times 3 squared times 5 squared gives us 900. Hence, the HCF of 2700 and 3600 is 900. So that's how we can apply the concept of HCF in real-life scenarios and even more advanced examples. The key is breaking down the numbers into their prime factors and identifying the common ones. In today's lesson, we explored the concept of the highest common factor, HCF, a crucial element within the study of numbers. We began by defining the HCF as the largest positive integer that divides two or more numbers without leaving a remainder. We also illustrated the significance of the HCF in simplifying fractions. We then examined two primary methods to find the HCF, listing factors and using prime factorization with a Venn diagram. In the listing factors method, we identified all factors of the given numbers and selected the largest common factor. In the prime factorization method, we broke down numbers into their prime factors and used a Venn diagram to visually represent and identify the common prime factors. By mastering these techniques, you can confidently determine the HCF of any set of numbers, making your mathematical problem solving more efficient and accurate. With practice, these methods will become an invaluable part of your arithmetic toolkit. Watch the rest of the GCSE Maths course at Sophos Education.